Hello, today I am going to discuss about bitwise logical operation instructions. So let me create a new file. Maybe I insert a few new rungs and instructions. Okay, so then you can click and select this move or logical tab. Just click this move or logical tab, and then you can see here. This is a bitwise logical and bitwise logical OR, bitwise logical XOR, and then bitwise logical NOT. Okay, this is a logical operation instructions. Okay, so you can click this and then put here, and then click the OR, put here, click the XOR, put here, and then click the NOT instructions, and then put here. Let me make it smaller, okay, so that it will be easier to see a bit. Okay, so I will insert a virtual switch here. Okay, let me assign address. Okay, maybe I will use binary address, so b3 column word 0 bit 0. Okay, so I'll copy this to here, this to here, and copy this to here. This I will change to bit 1, this I will change to bit 2, and then this address I will change to bit 3. Okay, and then I need to assign address for individual bitwise logical instructions. Okay, so this, okay, what is bitwise? Bitwise comes from the word bit. Bit mean binary, so it must be the binary uh, value, right? So you have to use the binary address also. So I can click this binary data file and then pull from here to here. Okay, I increase the element number by clicking the property. Maybe this one I increase to 10. Okay, so maybe make it bigger a bit so that it'll be easier to see. Okay, so this aside to here. Sorry, maybe this one I will change to decimal format. So this is a binary b3 column 0, binary b3 column 1, binary b3 column 2, and so on. So I will drag this address to here, and then this address to here. Okay, and then this I will drag to here. Okay, if you notice, okay, I use b3 column 0. Okay, this 0 is a word 0, this 1 is a word 1, this 2 is a word 2. One word represents 16 bits. Okay, if you click this radix box and select binary, you can see, okay, word 0 consists of 16 bits starting from bit 0, bit 1 until bit 15. Similarly for word 1, 2, 3, etc. Okay, why I don't use the assign the individual bits here? Because this I want to perform the bitwise logical operations. Okay, later I will explain further. Okay, so this I will copy the address to here, then to here, and then to here, and then to here, to here, to here, and then to here, and then to here. Okay, so this I will change the bit number. Maybe I will change the word to 3, and then this to 4, and this to 5. 3 1 0 1 2 3 4 5. Sorry, this one I changed to 5, change to 6, change to 7, change to 8, change to 9, maybe Okay, this one I'll change to 10. Okay, and then let me compile the files by clicking here and here to make sure there's no error. And then I will click here and click download. Okay, you can save the program into your computer hard disk. Okay, you can you can give a name to your file. Maybe I will say bitwise logical, okay, operations, and then click here and click run to run the program. Okay, let me put this one, sorry, let me put it let me put this one to the right, and then I will select binary. Let me zoom it to make it bigger. Okay, all right, make it, maybe I make it bigger bit. Okay, so for example, maybe I change the bits here, maybe change to 1. Okay, if you see there's an alphabet H here. H stands for hexadecimal, so this value is in hexadecimal format. Okay, you want to see the equivalent hexadecimal value, you can click the radix box, then click here hexadecimal, then you can see this is a hexadecimal value. All right, okay, so maybe here I will change to 1. Okay, I randomly change the value so that I can show you what is the difference. Okay, maybe this is a 3. Okay, 0 1 2 2 is a result of the AND operation, and 3 4, so the 3, maybe this one change to 1, this one change to 1, this one change to 1, this one maybe change to 1. Okay, 5 is a result, then 6 7. Okay, 6 maybe change to 1, maybe 1, maybe 1, maybe 1, maybe 1, maybe this one change to 1. So 8 is the result, so 9, this one I will change to 1, change to 1, 1, 1. Okay, so this one. Okay, so this bitwise AND instructions is none other than the normal AND logical operations that we had learned in the previous video. Okay, so this instruction will perform the AND operation. Similarly, for all instructions or bitwise inclusive OR instruction, it will perform the OR operation. Similarly, for the XOR and NOT instructions. If you want further detail about all these logical operation, you can refer to my previous video. I have a video that talk about all these logical operations. I'm not going to repeat here so that to save the time. Okay, so if I trigger this virtual switch to close, the virtual power will flow through this virtual run and energize the AND bitwise instructions. And then the necessary operation will be performed for the AND operations. Okay, in order to see and understand clearly, we can open the binary data file and then change the radix to binary format. Okay, so if this is manually triggered to close, what happens is an operation will carry out. So this source file b3 colon 0 and b3 1 bits, okay, it will perform the AND operation. AND operation means 0 0 will be 0, 0 1 will be 0, 1 0 will be 0, 1 1 will be 1, right? It's just like a normal multiplication. You can see 0 0 will be 0. 0, 1 will be 0. 1, 0 will be 0. Okay, if 1, 1, then it will be 1. Okay, let's say I set this to 1. Okay, now nothing happened because I have not yet triggered this virtual switch to close. Let's say I trigger it to close. You can see it will manually perform the operation, and then it will save the end result into the destination address, which is B3 column 2. B3 column 2 here. Okay, okay, you can see 1 0 0 0 0 0 0 1 0 1 1 will be 1. You can see the hexadecimal format here by clicking the radix and then click hexadecimal. Then you can see 881, which is this one. 818 hexadecimal value, which is this one. 800, which is this one, in hexadecimal form. If you want to see the decimal value, you click the radix and click the decimal. Then it show you the equivalent decimal value. Okay, now let me select the binary values. Okay, so okay, now for this one, if I trigger this virtual switch to close, this OR operation will be performed for this address B3 colon 3 and B3 colon 4, which is this one. B3 colon 3 and B3 colon 4. So what will happen is the OR operation is like that, just like a little bit like a addition, but it's only slightly different. That means 0 1 will be 1, 1 0 will be 1, 0 0 will be 0, 1 1 will be 1. Okay, you can see. Okay, let's say I toggle bit. You can see what will happen. See, 0 0 will be 0, 0 1 will be 1, 1 0 will be 1, 1 1 will be 1. Then how about this XOR, exclusive OR operation? So once I trigger this virtual switch to close, this exclusive OR will carry out a exclusive OR logical operations. Okay, you can see the address is B3 colon 6 and B3 colon 7. Okay, for this B3 colon 6 and B3 colon 7, the exclusive OR or XOR operation is like that. 0 0 will be 0, 1 0 will be 1, 0 1 will be 1, 1 1 instead of become 1, it becomes 0. Okay, let me trigger this to close. You can see the result. Okay, you can see now. See, 0 1 will be 1. Okay, 1 0 will be 1, 0 0 will be 0, 1 1 instead of 1 it will be 0. This is exclusive OR logical operation. How about not? Not is just like that, is to perform the reverse or opposite operation. Is 0, it becomes 1. 1, it becomes 0. Okay, you can see this address. The source address is B3 colon 9, right? So for this NOR operation, 0 become 1. 1 will become 0. Alright? Okay, let's say I change this value first. Okay. Now nothing happened, right? Because I not yet energize the NOT instructions. Let me energize by switching this virtual switch to close. See, you can see what happens. 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0. So that's it. That's all.